Greetings again. So this is the last lab of the semester, and this is the vibration VB, lab VB. I don't really know what it stands for, but yeah, so spring mass damper characterization. So for this, the equipment is fairly straightforward again. You just have a motor. We have another strain gauge, and coming back to your SM experiment, you should remember how to connect this. So because it's just one strain gauge, we're going to connect it in a quarter bridge configuration. So again, we have the same equipment as last time and same connections. So the two cables coming in, we're connecting a jumper lead to the 350 resistance. So because this is the same strain gauge, we can do that. So we just kept it at 350. And now we're just going to follow along on the PC. So again, we'll just connect this up to the PC. Cool. So that is on, and now we move here. So the same thing as last time. So turn on the software, move it to the side. So the first thing that our procedures tells us here is to select your channels. So again, the same stuff as last time. Turn the other 3 channels off because we've only used channel 1. Hit OK. And then from there, we meant to set the bridge configuration for this one channel that we have set up. So we have a quarter bridge because there's only one. And then we hit OK again. And then from there, we're going to use the scaling. So again, this is just like properties of the strain gauge itself. So change that to 1, just same as last time, because we're only using one channel, we only need to change 1. And hit OK. And then from there, come back to the balancing again. So make it 0, because right now we are not touching it, so it's meant to be 0 at this stage. Close that again. And now that the beam is balanced, we can check whether this is working using the usual method. So because the strain gauge is at the top, if we push the beam down, that means it's in tension. And if it's in tension, that means you should have a positive reading. And the same goes for the opposite direction. So if I flex the beam up, then I should have a negative reading. This shows that our strain gauge is working and all of our equipment is working. It's returned back to close to 0. So that's always a good sign. So now what we're going to do is turn this off and change it to an analog signal, because we need to use the oscilloscope for this experiment. So I'm just going to power it off. And then from there, we come onto this display over here. And the way to change it from, so right now it's set up so that all of the data is coming through this and going to the PC. But we don't want that. We need to make the output signal analog, so that we can connect it to the oscilloscope that we have set up over here. So now we're going to change it to an analog signal. So we come to this and we can just go into the menus, follow along in the procedures, and it says you go towards options, change the output, and it says analog out, which is currently off, but we need that on channel 1, because again that's the one we've connected to. So we're changing channel 1 into an analog output. And then the settings also say this needs to be normal. So once it's normal, just hit menu and you should be out of there. And then from there we can connect the BNC cable, make sure it's connected properly, and turn on the oscilloscope. So just hit auto set, the shortcut, and then from there we have it so that we fiddle around with the division and the voltage division and the time divisions. And what we want to do is deflect the beam 1 inch down and then let it go. So what this will do is it's creating an oscillation, and that means your strain gauge is changing from a state of compression to a state of tension on every cycle. And this change can then be recorded as it goes through here, and it goes onto the oscilloscope. Right, so what you'll see is as I push this down, you'll see that the value increases, right? So I haven't released it yet. So there we have it. So what I'm going to do is hold it up there and then just wait for it to go along the whole screen, and then as soon as it's ready, let it go. So what you see over there is damping happening. So obviously the amount of displacement has reduced. That means your tension has also reduced, your compression has also reduced, and you want to record that wave. So the way of recording that wave is by pressing the run and stop button, but because this was just for explanation, I'm going to do that same thing again and then press the run and stop button. So again, I'm just going to release it. That produces a dampening, and then from there we just wait for it so it records to the whole screen, and then when we close we just press stop. So this is our signal. Coming back to this wave, so we have to measure the frequency of this damping. So what I'm going to do is zoom in using the section/division knob, and now we have the thing there again. Remembering from your first week, you use your cursors, and this time we want the time because we're measuring frequency. So then you readjust your cursors to get your frequency in the usual way we do, and there we have it. So that's your frequency. So the next section asks us to use the cursors on the oscilloscope to determine the logarithmic decrement by employing the logarithmic decrement method. So, and it also says that it's best not to use adjacent waveforms as they are very close in amplitude due to the small damping coefficient. Again, we use the cursors. This time we're measuring the voltage, which means the amplitude, and then we're changing it to figure out what the height is, what the amplitude is. So again, it's best to do this from end to end rather than halfway like that, because you don't know where the halfway point exactly is. So just do that and then count the number of waveforms and then measure the second one by lowering it. So like in this configuration, like the one that intersects my cursor is the amplitude we're measuring. So you're just trying to maximize that number so that you get decent data, and then you obviously use your delta to get your readings. Again, so this data will be provided to you guys. So again, just to refresh, you figure out your amplitudes and count the number, and you figure out what the damping coefficient is. Now for the second part, we're going to use the motor attached. So the instructions say that we have to set the voltage on the power supply to 15 volts, which we have already done. And then from there, what you want to do is connect your motor and just try and damp out the oscillations at first because it might be a bit rough. And then once it starts, the motor picks up speed and becomes stable, then you can let it go. So I'm just going to do that right now. So there we have it. It's spinning. Just help it stabilize. So as you can hear, it's getting louder. Come back onto here. Adjusting the waveform. And then press stop. Just going to power this down so it stops making noise. And then from there you can obviously just do the usual stuff. Adjust the sign, adjust the wave rather, and try and get a decent frequency. Again, just use the cursors and you can get your frequency that way again. So now that we've figured out the driving frequency, which is essentially the frequency of this wave, and the amplitude, the instructions tell us to reduce the voltage and record the same values again. So they've given you a table to follow, and you're meant to record the peak to peak amplitude of the strain and the driving frequency according to your change in voltage. And once you've done that, you power the power supply off and get set up for the second bit. So for the second bit, what we've done is we've added a damping mass at the bottom over there, and now we're going to repeat the same procedures again as the first one. But now, because we've added a mass at the bottom, the balance from the strain gauge is actually gone. So what we need to do is change it back to digital, balance it on the PC, using the usual way. Just bring up the software and hit the 0 button in the balance menu, and then from there change it back to analog, and then repeat the same experiment. So what we're going to do again is set it to 15, turn on the motor, let it reach its stability, and then from there record it on the oscilloscope again, and the usual peak-to-peak measurements of the strain, and then you also have the driving frequency using your cursors, and that will have to be done with 15 volts, and again you're going to reduce the voltage in increments as defined by the procedures, and then you reduce it until you get all of your data set. So that's it. That's how you collect the data for this experiment, and this data will be provided to you. So you use that to do all your calculations and write your report. Thanks.